Alright, normal pre-stream ramble, I'm just waiting for everything to get properly set up, and there we go, we've got video. So this is going to be a couple more tests on the Wanptek KPS305D cheapo lab power supply. This time we're going to be using my constant current load, which you can see there, horribly overexposed. But there's a computer controlled load, and you can see the software running for it on the right there. And we're just going to be testing the Wanptek at a couple different voltages and a few different currents within its range, the same ones we did the last stream. So this constant current load is entirely isolated, so we're not getting any additional ground loopage through it. So we should really just be quite straightforward in doing these tests. So let's just jump straight into it. You're going to be viewing the scope right there. If I can manage to get the camera in place, which is not an easy task. Which is good, so we can get a couple extra live viewers. There we go. So that's connected up right the same way as yesterday. We are using the external filter, which we devised in the last stream, and that's a 3.9 millihenry CMRR choke out of a power supply. On the output, straight on the output, just connected on the banana plugs, as well as a 100 nanofarad and a 6.8 nanofarad capacitor on the output of that. I'll just show that if you're viewing this for the first time. There we go, that's our extra output filter, and that gives us rather reasonable output performance on this power supply. I think if you can get this power supply, you should be putting something in like this in place anyway, because the output is pretty much absolutely horrible without any external filtering. This can easily be integrated into the case of a unit. So with that out of the way, let's just jump straight into it. If I can get this thing to sit again. There we go. This is very professional. And people are showing up in the chat. Do you remember when we talked about dildos? Yes, but we're not going to be doing that today. So if we have a look at the software for the constant current load, this is a alpha software, so it's not too beautiful or practical, but I'm going to be setting the output current here, and you're going to see the actual set current here. We're only using address 0 there, and that's about it. We don't have... Well, we could actually just connect up the voltage sense as well, I suppose, so you get a nice voltage reading for the power supply. That's going to make everything a bit better. So let me just find the correct clamps. There are 8 clamps on this load since it's a quad channel device, so bear with me. I'm just going to clamp these straight onto the output where we're tapping off the scope. We should now be getting a voltage reading on the computer monitor. And yes, we are getting, you can see 5.004 volts, so this meter is quite accurate. So that just gives you guys a bit of feedback on what's actually coming out of the load. So you're going to have voltage output there, current output there. So the range of the load is about 100 milliamps to 10 amps. We're going to be testing it at 100 milliamps to 500 milliamps, as you can see, as per these steps. And we're going to be testing at 15 volts, 10 volts, and 5 volts. At the 5 volt setting, we're not quite going to be able to push the full 5 amps. We're going to peak at about 4.2 because the constant current load isn't really made for voltages that low. But for all the other data points, we're going to be using quite accurate currents. And the load also has a very slow feedback loop, so it's not going to be particularly affected by the ripple. It's going to just keep drawing its calibrated current, since it takes milliseconds for it to adjust. So let's just get this going. We're already set up to do 5 volts at 100 milliamps. So let's start the load. And you can see that we're getting a reading on the scope. And you can't see, but the display on the power supply is coinciding with the display on the computer monitor. So I'm just going to jot down that's 32 millivolts of ripple. And we'll stop that, go up to 500. And that gives us, I'm going to call that 16 millivolts. We'll stop and we'll do 1000. And that leaves us with 23 millivolts. Stop that, do 2 amps. And that gives us what are we going to call that? I'm going to say 18. And we'll do 3 amps. I can see that the constant current load is somewhat angry with me. It's not quite coming up to the set current. It's going slightly lower since it just can't quite handle 5 volts properly. You can see how all the calibrations are going slightly out of whack. It's not -7 degrees in here. So we're drawing like 2.7 amps really, but it's good enough. And that's giving us 24 millivolts of ripple. So the 5 volt is going to be a bit off because, yeah, we don't have a proper setup to test for that. Anyway, we'll do 4 amps. I could just use the software to recalibrate this actually. So let's do. We're getting 3.47 amps out of the actual power supply, out of the actual load when it's set to 4. So we'll do 4.5 and see if we can actually push it up to 5. 3.83, 4.9, not 492 milliamps. This load doesn't have any actual digital feedback on the set current. It's just a digital controlled op-amp circuit, and that's giving us 4.11 amps. So we'll do 4800 milliamps on the setting, and that might get us close enough to 4 amps. And that's giving us 4.04 amps. And at 4.04 amps, we've got I'm going to call that 45 millivolts of ripple. So let's redo the 3 amps as well, since we can actually get it up to quite accurately 3 amps. Let's do like 3500 milliamps on that. That's giving us 3.08 amps on the display, and that's giving us 30. I'm going to call that 31 millivolts of ripple. 31. And finally 5 amps, so that's going to be like 5500 milliamps. We don't want to run into the current limit because that's going to cause the load to reset, and that would be just a big bother. So we're getting 4.52 amps in reality. Let's do 5900 milliamps, 4.8, 6100, oh, we accidentally caused the load to reset that, so it's going to take a sec for the software to regain communications. The load is booting up right now. Just outside of the screen saying but there we go. So let's do 6,000, and the tabbing is all weird in this. And let's see if we can do that without resetting it. That's giving us 4.86 amps, so perhaps we can still get it to 6100. Let's see. No, that's just causing it to current limit, so we're not going to get much more than 4.8 amps on the 5 volt setting. What are you trying to achieve? We're testing the output of a Wanptek using a constant current load. In the other stream I did on this thing, we were using a resistor to test it, and that means that we were testing different voltages and different currents at every test point, so we couldn't do 100 milliamps at 1 volt, 100 milliamps at 2 volts and so forth, but we had a constant voltage and current setting. Voltage and current were tied together as they are by Ohm's law. And using this digital control load, we can just set 15 volts, 1 amp, 15 volts, 2 amp, and it's always going to be 15 volts, and that's going to give us a bit more controlled circumstance for testing. So let's just see if we can get it running at 4.8 amps here. Yeah, 4.86, so that's passable for 5. And that's giving us, I'm going to call that 58 volts, millivolts of ripple. So that's our performance at 5 volts, and that's actually not too bad. Now we are, since we're just doing 5 volts, it's all rather low power stuff, so it's not surprising that it would perform well at this low voltage. What is your limit for ripple voltage? There's no limit for this test, we're just trying to see what this load will do. I mean, low is better of course, but yeah, we're just experimenting. Wasting some time. So now I'm going to turn the load up to 10 volts, and we're going to do the exact same thing all over again. That's 10.0 volts, you can see that very well there. We will setting for 100 milliamps. And start the test. And that's giving us, what's that? Now I'm going to call that 19 millivolts of ripple. 500 milliamps. Gives us, I'm going to call that 17. 1000 milliamps. In other words, 1 amp. Whoa, we saw quite a big dip there as it turned on. But that gives us, I'm going to call that, what am I going to call that? 18. So this is rather low ripple, I must say. In large part due to our external filter. 2 amps. That's a solid 20. Still rather low noise. 3 amps. And we're seeing a significant rise, going from 20 millivolts to about, I'm going to call that 36. 4 amps, and this time we should get the proper 4 amps, since we're actually running the load at a voltage which it's rated to handle. And yes, indeed, we're getting 4.02, and that's giving us a ripple of, I'm going to call that 50. And finally, 5 amps, the maximum rated power, or rather the maximum rated current for the Wanptek KPS305D. Let's see if we reset the load this time again. No, we did not. and we're getting, I'm going to call that 65 millivolts of ripple. So at double the voltage we are getting somewhat higher noise, but not hugely higher. So let's step it up to 15 volts, which is pretty much the maximum this load can handle. We can probably go to 20 if we want to, without exploding it. We might do that if I feel dangerous. So now we're doing 15 volts, and we're going to do the same thing, 100 milliamps. Start. And that's giving us, I'm going to call that, I'll get some 50 hertz crap coming through there. I'm going to call that 18. These thingies are definitely 50 hertz derived, just passing through. Moving on to 500 milliamps. That gives us, I'm going to call that 18. One amp. Ooh, big dip there when we turned it on. And 1 amp's giving us, I'm going to say 20. Two amps out of a Wanptek KPS305D is giving us, I'm going to call that 25 millivolts of ripple. Three amps, and again we're seeing a dramatic rise in the ripple voltage as we go past 2 amps of output, and now we're seeing, I'm going to call that 38 millivolts. And 4 amps at 15 volts out of the Wanptek KPS305D is giving us a ripple voltage on the output after our filter of, I'm going to call that 55 millivolts. Finally, 5 amps at 15 volts will give us a ripple of, that is a solid 68 millivolts. And that's all the charting I've got written out thus far, and clearly we're seeing exactly what we would expect. Higher power output gives us more ripple, and it's performing quite well actually in the low output as well. So that's pretty much exactly what you'd expect. Nothing very dramatic going on at all. Now let's do an experiment. Let's actually do 20 volts as well. I'm not, the load we're using is only rated for 150 watts per channel, and it's made for low voltage loads. However, since we're limiting ourselves to 5 amps, theoretically it should be able to handle this. It's not going to be able to measure the voltage because that maxes out at just about 19 volts, I believe. But we'll see what happens. We'll turn it up to 20 volts. Everything's powered by 7085, so the power regulation shouldn't be an issue. But the transistors would overheat if we were to actually run this load at its rated 10 amps of sinking power. Yeah, now we're just voltage limited on the measurement, so I'm just going to disconnect that. We're at 20 volts, so let's do 100 milliamps to 5 amps on 20 volts and see if we explode my constant current load in the process. I've never tested this at such a high voltage. It's going to work just fine if it works. The only issue we're going to run into is that it will blow up if we put too much power into the transistors. So 100 milliamps at 20 volts of output gives us, I'm going to call that 90 millivolts as well. And for Wanptek, and 500 milliamps, not 50,000 milliamps. 500 milliamps gives us, I'm going to call that 20 millivolts of ripple peak to peak. 1000. 1 amp gives us, I'm going to call that, I'm jumping around a bit, so I'm going to call it 20. And 2000 milliamps gives us a giant dip as we turn it on, and that's 28 millivolts. Three amps. 3 amps again gives us a dramatic rise up to, I'm going to call that 39 millivolts. Really big rise there, going from 2 to 3 amps. 4 amps at 20 volts gives us, I'm going to call that 49 millivolts. And finally, 5 amps at 20 volts gives us an output ripple voltage of, I'm going to call that, jumping around too much, I'm going to call that 64. So all in all, we're sitting quite happily under 100 millivolts of ripple on all the tests we've done today, which really isn't too bad. It's not going to be anywhere near as good as, for instance, my TTI power supply, but it certainly is a lot better than without a little filter. I'm not going to bother testing this without the filter because it's just, we're just going to see such horrible results. Like at 5 amps, we're going to get that half volt of ripple which we get out of this device at its stock config, and that's just entirely useless, really, for any kind of real power supply duty. So I'm just going to leave it at that. Quick, short stream. Thanks to everyone for watching. If you like this kind of stuff, do like the video and subscribe and leave a comment and all that good stuff. And I'm going to leave you with that. Cheerio.